here. All right, let's see. The people that are absent, or the senior that is absent. I set up the schedule here. So we're going to do 5-5 today. We have 5-4 that's due. So that means we are going to do a review day. I'll send a study guide tonight sometime to you guys here. We'll have a review day on Monday, and then the exam. Looks like an exam is set up for the 2nd. That's kind of what we're looking at on that. So jam with that. Back to here. And any questions on anything on 5-4? Let me finish up that, just make sure we're concluded on that.
Yes, because I had to do it yesterday. The honest problem is confused.
Okay, let me see if that.
The other one's well done.
Let me see if it's going to take super long time or we're going to be okay here. What is the problem itself?
45, 49, and 53. Basically just continuation from 41 and every other all.
Okay.
But the formulas inside of the identities just look like that.
Got it. Okay. So let's see. I don't mind doing which one's the one that's the most trouble? 45, 49, 53? Which one is the?
I don't know, 49, 53 probably.
Okay.
I have no clue.
Gotcha. Okay. We'll work it. I'll give you one of them done here. So, okay, class. Class, help me out here as well. You guys talk to me because this is not new information here. It's still just continuation of stuff that we learned here. So I have a cosine theta over 2, or cosine square theta over 2. A tangent theta plus sine theta over 2 tangent theta. I'm thinking I want to get rid of my half angle or double angle. I want to get it to a single angle, but especially there's only one formula I had. So flip to this one here, thinking to myself, hey, that's a square though, right? That's a square form. If that's a square form, I'm going to just put it like this here. So that means this is going to be the square root of
1 plus sine. Oh, that's at a half.
But if it's squared, you just don't have the root square root sign.
So that is going to cancel off the square root sign. Then in here. How do I get one to the other?
Yeah, both tangents to cosine.
Okay.
And then multiply top for the top half. Like, that would make sense.
Yeah, I just want to see what that's going to happen here. So yeah, big thing that happens right here. A complex fraction on our side, on the right-hand side. The left side looks nice and easy. So I figure it's going to convert to that somehow, hopefully. And so how about make this into 1/1, and let's multiply this guy by a cosine theta over cosine theta. That'll at least give us somewhere. So that means, let's see if I can squeeze it into here. So that means I have a sine theta plus sine times cosine theta all over cosine theta. Oof, barely got in there. And this one is 2 sine theta over cosine theta. And we learned something.
We know if this has the same denominator.
That is so funny how that happened. So funny how that happened. When you cancel cosine, you're going to get. we're gonna get sine theta plus sine theta cosine theta all over 2 sine theta. It looks like the same thing, except sine got replaced with tangent. That's funny. All right, anything else?
We know formulas for double.
Oh, we have no more, we have no double angles though. Yeah, just everything. Just a little bit of algebra here, just a sophisticated algebra. Just love it. Since I have sine on both sides, can I factor the sine? Let's do that. I'm gonna sine on the outside.
Yeah.
So the algebra was just a tiny bit more involved. That's it. And now I have matched both sides, and I can say, ta-da, ta-da, ta-da. Cool. Yeah, so it'll work out something like that. Isn't it?
Wait, and one quick question.
Yeah.
With tangent, because I need to put tangent into one of the two, which one would I pick? I was confused by that last time.
Oh, got it.
I can
You
do the rest of
problem.
them, I think, but I'm probably gonna end up.
Let's see.
Does it not
Is
matter if you're not actually putting numbers into it?
for the most part, it doesn't matter, but let's see what we have here. If you think about what is the reduction of cosecant? Cosecant is cosine over sine, right? Oh, sorry. Cosecant is 1 over
Sine,
sine.
and cotangent is cosine sine.
Yeah, so it looks like I have sine on the bottom,
So I would do the top one.
the top one.
Oh, okay.
Because that'll get you to your answer a little faster. Cool. Yeah, they were just slightly more complicated on the proofs. Okay, we're good there. Let's jam. 5.5. This is so cool. It just says additional identities. Just all the stuff we haven't covered yet.
We need more of those.
As if we did not have enough. Uh-huh.
For the presentations this semester, if you find something that you like, we just do it at any point. or-
Yes, correct.
So I can hypothetically, if I found something I wanted to present for like maybe year two, I'm not
I mean,
saying that I haven't seen
yeah.
it, but
Yeah, maybe like halfway through the semester,
Okay.
because we're gonna get into law of sines, law of cosines, and we're gonna get into, yeah, I think once we're like in chapter 7, I think that's a good amount. Where we're good there for that. 8. Yeah, it's a second to last chapter. I figured there's enough content now. All right, let's see. Additional identities. There's actually 2 different kinds. There's something called product to sum and sum to product. So it's almost like how do you connect the summation formulas, right? And then all of a sudden this like multiplication formula comes out of stuff. Like, what is this cool? Okay, so let's begin.
There's so many different formulas.
Yeah, chapter 5 is just crazy. The more you look at the formulas more often and just kind of have it in front of you, the more they become sort of part of you. You memorize them, you become familiar. So I encourage you guys to do that. Don't do the homework without having a formula sheet in front of you or just having your textbook open to the front cover. You know, just kind of seeing them, and then go from there.
It's kind of spread out.
And yeah, at this point, I probably wouldn't even do the notebook. I just look at the front cover and getting used to seeing them in that position. Okay, so 2 different sets of formulas come out. Let's go with it. So have you guys seen this formula before? Sine of A cosine B plus cosine A sine B.
That is the sum formula.
Oh, cool. Okay, so let me put on this end though. Sum formula for sine, and Abe knows it. Awesome. Okay, let me give you another one. How about sum of A cosine B minus cosine A, sine B. That sounds good by me. Doo-doo-doo. I just think it's such cool, you know, when we started off chapter 5, right? It was just this little graphic, right? Of a two congruent triangles on a graph, right? And yeah, we built all this up just from that little piece. All right. Oh, hold on, real quick here. This is whoa. Let's see. If I do this, you guys tell me what happens with that.
Choose sine of A cosine of B.
2. Okay, that's cool.
it
2
on that side.
sine of A.
You go plus
Cosine.
cosine of A, minus
No.
cosine of A.
Sine of B, so they
And
can't
if you
figure
add
it
it,
out.
yeah.
Yeah, these guys are gone, right? We have a cancellation. Remember in algebra, it was called elimination. Remember that elimination techniques from algebra? We get two.
Oh, there's like the substitution.
Uh-huh.
Oh,
Yeah, you
I
get-
forgot.
No.
You line them up so that they're opposites of each other and just add them up and that will cancel. That's so cool. Okay, so I got that. So that means I have this. This is sine of A plus B plus, right? There's a plus sign because we're adding these guys up. And I have that. Okay, what do we have here? Let's divide both sides by 2. And so notice what I have is I have this interesting concept that happens is 1/2, and I got to put little brackets here. The brackets because I got parentheses and everything else in between here. So I'm going to go like this. Boom. Okay, that is called the product to sum formula, and we'll list them all in just a bit here. Okay, why we say product to sum? Because we have a product of 2 trig functions. And we break it down to a sum of the angle measurements.
Wait, does that mean that to get this, we have to like to get a product of 2 measurements, we have to use the sum and difference formula?
Kind of, sort of, but not use it, but just this little piece of it right here. We're going to add the 2 angles together, take sine of it. We're going to subtract the 2 angles, take sine of it.
Okay, so we don't actually have to like, use the whole formula.
That's why we've developed like a shortcut formula for that right
Okay,
there.
So that's,
That is it right here. This is the product to sum formula for that one. Now there are 4 more based upon the combination that we use for these guys. So we can actually develop all 4 of them, just a lot easier to write them down.
can you use that formula for anything, or is it just cancel?
Say again, Dylan.
Can you actually like use that formula and get something out of it, or is it just an answer for what you would get out of it?
Yeah, this is just the answer you get when you added them. So then, go ahead.
So
How about
we're
if
not
I-
making new formulas, we're just adding them together, so what happens?
Correct, yeah. We're gonna take the sum of different formulas and we add those together in some combination to get what we
The
want.
answers for like all of these are technical formulas. 'Cause
Mhm.
proving that they're true.
Yeah, you prove a formula and then like, cool, we get to use it. Prove another formula, yeah, we get to use it.
What would you be using that for?
How fun is
So it
that?
was like A was 30 degrees, B was 45 degrees. B was sine of A plus sine of B.
Well, you know what those 2 things are, just find sine of A and cosine of B and then multiply it, don't use the formula. That's what I'm confused about, because if you have,
Good.
oh, is it if sine of A and B are not the angles on the circle?
Correcto, That one,
But
and
then A
also if
plus
you have
B
a
is
product
the
that you
angle
don't
on the
like.
circle.
Uh-huh,
Got it.
cool. Let me list the rest of them. We good? So another variation, how about if we just, of course, right here, real quick here. How about if we were subtract the 2 formulas from each other?
Are you gonna derive all the different formulas?
No,
or just write them?
let me write them down the rest. Yeah, I just want to say, like, if you wanted to, you could subtract this, and what happens here? That goes away, you got a minus between the 2, but then these guys cancel, right? And you got yourself a different formula now. We're good?
Because now you have 2 cosine of A sine of B.
So I'm not gonna, don't need to derive all of them. So I'm gonna just go like this. I'm gonna go back to what we had before. And plus, okay. Cool. Okay, let's do the rest of them here. So I'm gonna write, next one down is if you were to subtract these guys, we would have had a cosine. This would have been left, is that right? That would have been left. So we have a cosine A sine B is equal to, really, in a sense, the subtraction between the two instead of addition, that's all. Boom, okay, there's that one. And then what we do is we use the cosine addition formulas, do the exact same thing. Add them together, the terms cancel. Subtract them, some other terms cancel.
What would we call that one?
These guys are called the product of sum formulas. So if you
Is
want,
that other one product?
yeah, all of them.
Difference? Because
It's still
Yeah, still a sum.
some of the name. I don't know if it's subtracting that. We don't have like one for sine, one for cosine, it's just all the product of some form.
Yeah, Product of sum formulas are 4 of them. There's 4 of them. So that's first 2. And these guys are derived from the sine difference and sine sum formulas. We good?
Now can.
No, this section are just gonna deal with sine and cosine only. That's it. No tangent. Two more derived from the cosine addition or sum and the cosine difference formula here. So this is gonna be cosine of A times cosine B equals to 1/2 again. Cosine of A plus B plus cosine of A minus B. There's that one. And last one, if we subtract the two formulas together instead of add, then we get sine of A sine of B is equal to 1/2 cosine of A, and then we could just switch them around. So now notice there's a switch here. Yes, they are also here. They're called the product of sum formulas. And then we're also gonna, they are, if you see your textbook here, product of sum formulas are right here.
So.
We can derive them if you guys like. That's no
okay.
problem with me.
I'm just curious about one thing. The bottom one,
Uh-huh,
currently here, it's A plus B and then A minus B for both.
uh-huh.
The cosine one, you have it written A plus B, A, it's a plus and then a minus, and the other one is a minus and plus. Is that, are those meant to be different?
Yes, they're meant to be different. I guess you could, this is the way, I just wrote it the way the book does it. I guess you could write the cosine of A minus B first, right? Because adding one or the other doesn't matter. Right? It's just the way the formula, when you derive it, that's the formula, that's the way it sits.
The first
So they're
subtraction
right.
doesn't.
For subtraction, it does. Okay, so let me just check one thing real quickly. So we have identities to verify, that's true. But then what we do is we just use these products to sum, and we're going to do sum to products as well, to move one way to the other. We good? There's Isabel asks, is there almost like an application to this stuff? And I want to say no. It's almost like just a logical conclusion to what we've done already. So I don't think I've seen like a real life application to the sum and difference form or the sum to product to something. It's just verifying the formula sometimes, identities, there's identities that are made out of it, and then just using the formula itself.
There wasn't a lot of them.
No, just a few, just to get you guys comfortable with that. Okay, so let's do this here. Exercise 1. How about this? Write 10 cosine of 5x sine of 3x as a sum or difference. Cool there, and I'm gonna just check something out real quickly.
So let's call those two. Are they still a product? Those are some of the product.
Sum to product, let's give me the next one. 3, and this is to be.
Exactly. All four of the ones we just did are products. Not any further labels. Does the 10 only go to cosine or also the sine?
Say again, Sam?
The 10 at the beginning, is that for cosine only or cosine and sine?
It's a multiplier, right? So if your multiplier, like 10 times 3 times 2, right? It's just all multiplication, right? It doesn't matter which way you multiply, but it's a multiplier. The only time you would ask that question if it's a distributive property, right? But if it's just multiply, 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 then it's just a multiplier.
Then you put down the other side of the formula, it would just be a 5 instead of 1/2.
Uh-huh, that sounds good to me. Okay, but I just want to see if there's, this is my little extra book that I've written kind of over the years here to see if there's any application of this. Yeah, I guess there's, again, dealing with higher mathematics. So in calculus 2, there's, we figured out a way we're stuck because we're stuck in product mode, and we move into addition subtraction mode, and then we can take the calculus portions of it. And then sometimes we're stuck in added subtract mode, we jump into product, and then we use the chain rule for things. So we kind of have that rule. So yeah, there's application of in a little higher mathematics here. Anyway, so let's go with it. So we got this on our hands, and Abe says we have ourselves a 5 eventually. So, we're changing this piece of it, right? Is that what we're doing? All right, so cosine to sine. So I'm going to jump to, it's this one right here. Are we good there? The minus formula. And if that's the case, see if this makes sense. The 10 is still on the outside, but I've just changed this piece here into a 1/2. So I'm going to multiply this here. Cosine sine, okay, so this is gonna be sine of 5x plus 3x minus sine of 5x minus 3x. Okay, so I got myself a 5, are we good there? Boom. And how about a sine of 8x minus sine of 2x, are we good?
Yeah.
Cool.
There need to be parentheses now though. Because the 1/2, 10 times 1/2 is that multiplying everything.
Good, yeah, waiting for that. So then at this point, you do need this parentheses. You've just changed it so that it's not just multiplication straight across. There's a addition or a subtraction. That 5 for sure needs a parenthesis on the back end. Say again?
You want in parentheses because there's only one.
Yeah, you can keep brackets, yeah. We normally do is brackets are a-okay. If there aren't any other grouping symbols, then we normally use parentheses, but it's still just fine to do that as well. Okay, are we good there? Let's see, verify. I'm wondering if you have any formulas to verify.
Now we're just gonna be, is that what this is almost gonna be like, kind of?
Say again?
Is this what the homework's gonna be like, but like obviously harder than this, but like.
Yeah, essentially for that piece, yeah. So let's go to the next one here. Let's derive the next one here, and then we'll deal with the inverse formulas here in just a second here. So, dun, da, da, da. So I have this little situation. So let's go the other way here. This is called sum product. So let's go the other way. And so let's pick on one of them here. Let's see, let's go over. This is a, let's see. I'm debating here. Should I just give you the formulas or go for it here? So what I want to do is I want to notice we have the A and the B here that are being added together. I want to make this a single value. This is a single value, that's a single value. So that means it allows me to go backwards now. So if that's the case, let's do it. Let's derive it here, at least the first one here. So how about this? I'm going to say alpha. Again, have to use a different letter, right? I'm going to just use alpha. Alpha is A plus B. And then I'm going to use beta, which is a Greek letter. I'm going to use it as A minus B. Same exact concept, same exact everything. We're just going to move things around. So if I were to add this up, I have alpha plus beta is equal to what? 2A. So that means A is really equal to alpha plus beta over 2, right? I'm going to see if the identities are given that way. Yeah, okay. And so your book actually writes them as alpha and beta. Okay, I got that one. So then hold on. If I go the other way, if I set it up like this, and I subtract this time, what do I get?
The opposite, so to be.
Alpha minus beta is equal, divided by 2 is equal to B. Okay, are we good there? So trying to isolate those guys to be their own little pieces here. So let me go back over here. I'm going to take this formula now. And remember, what I need is I just need a single angle here, right? I need a single angle over here. And so with that, yeah, good there. That formula there, let me rewrite it. So sine of, we'll write it in there, sine of A, cosine B. You guys help me out and make sure that's the way I'm writing them down. This is sine of A plus B plus sine. Sine of A minus B. Again, just a logical conclusion in mathematics. If that's true, tell me if you guys agree. This alpha, this A value is really just this right here, right? You got two things happening there. This cosine is now alpha minus beta divided by 2. This is 1/2. And what is A plus B? That was alpha, and this was beta. Okay. Let's multiply by 2. Let's multiply by 2, and I got myself this, again, just a logical conclusion off this stuff. And it's much more so that we have a connection between the angles on this one here. Okay, are we good there? Again, one like next logical conclusion. Let's write them out. So I'm going to put this one over here on this side to write them out. So the 4 formulas we have: sine of alpha plus sine of beta is equal to 2. Sine of alpha plus beta divided by 2 multiplied by cosine of alpha plus beta over 2. Done with that one. Okay, if we derive the other one, and we did the same thing, they're going to all look the same. It's a minus sign this time because it was the subtraction between the two. And then let me just check here, go over here. Sorry, guys, going backwards in time. Yeah, cosine went first, then sine. Okay, cosine went first and then sine. So it's cosine. This time cosine is going to be our first angle measurement. Sine is on the back end because they flip on each other. Okay. The addition of cosines. And last one, the difference of cosines. This one's a kind of funny one. It has a little negative next to it. So whenever we subtract, we're subtracting the two from each other. Since we use the same angles, it changes. That little last one was always a little different, huh? It was the same thing. It was slightly different on our first formula set. Yeah.
Unless I'm mistaken, the first two, the side ones, the things on the right side are identical.
Like, thank you so much. That was me. These guys should all be minuses. Sorry, minus sign, minus, minus. The first angle is always plus, and the second angle is always minus, because that's the way we built our definition.
Why is cosine the same thing minus theta? Why is sine? I know we solved for sine, obviously, but why is cosine something minus?
On the last one, the very last one?
Or no,
What's minus 2 sine?
sorry,
That's a minus.
how did we figure out what cosine? We solved what sine was, so how did we figure out what cosine? So just in general, or
Talk to me, Dylan, here. Just want to make sure. Ding, ding, if I go back in time, it's because we built these
it's just
definitions.
because we're using, okay, so we're just using A plus B. All right.
All right. No problem. Should we derive the last one? Because there's a little minus sign in there out of nowhere.
There's a level one for this one?
So again?
There's another one?
No, that's it. There's your 4. None else beyond that.
Oh, okay.
We learned that 8 new formulas.
8 new formulas today.
Wait, so are we mainly gonna be using the ones with alpha and beta?
Just,
For this one, yeah, use alpha beta to simplify things. Okay. So let's see, using the formula itself, that was okay. Let's see, write this expression. Yeah, so let's do that here. So just to practice with it here. What are we on, 2? Okay, and then we'll get into one more little aspect of 5.5. Cosine of 5x minus cosine of 3x.
So are we supposed to use the formulas now with alpha and beta?
let's see, on the first one that we did, right? First one, notice on the first one, there was a product here, right? You get a product between the two.
Oh, okay.
And so we're writing it as a sum or difference. Here is a sum and difference or sum or difference. You're going to write it as a product. So I just need to figure out which formula you're going to use. At this point, I think it's the bottom formula. Is that right? There's
Yeah.
two cosines and it's a subtract between the two cosines.
Wait, so in this, alpha would be 5 and beta would be 3, not negative.
Correct. Yeah. Beta is just 3. So the bottom formula is -2 sine, and it is the two of them added together divided by 2.
That's just 4.
4x. Then it's also another sign. Sine is the 2.
Just sine of
What?
y.
What do you
Whoa.
mean 4x?
I don't know.
It's the alpha plus beta. Which is 5.
Oh, okay, sorry, I flipped the two.
This is going to be 5x minus 3x divided by 2. Answer is
That's just sine of y.
that's just sine of x. Okay. Let's jump to time. Yeah, go ahead. Again, just getting used to the formula. That's
Why
all.
is alpha equals 5x plus 3x if alpha, beta are a plus b times a minus b?
Okay, alpha is a plus b, and then beta is a minus b.
But then isn't that alpha plus beta, which would be the two of them?
Well, let's go over here.
5x is alpha,
Oh, yeah, 'cause
3x is beta. You don't have a or b with it.
Right. So this is here's your relationship, right?
But then. Okay, what are we calculating? I thought that was sense.
Right. This is your relationship from alpha and beta and a, right? And then when you jump to the formula, when it gets the formula set up, so then it's the product, where the product is alpha plus beta divided by 2. Because we're using a as our listing. I know. Yeah, the two angles added together. Okay. Good. Okay. Next is, of course, prove.
Oh, I hate these.
Just one. Just one.
I don't know what I have one of the questions on, but it says proof.
This one here. Okay, prove that this is true. So negative tangent of x is equal to cosine of 3x minus cosine and sine of 3x plus. We always give you guys a minute here. You're going to have to use, obviously, what we've been learning.
You just have to make that fraction get really complicated and then simplify it. Because to do that, because those two were,
Simplify bandit. Done.
So, we'll go back to the last section. for 1 second.
Sure, absolutely.
confused.
We have
Oh,
a
wait, hang on.
subtraction of 2 cosines.
Same thing for both of them, what alpha and beta.
Say again, second.
Does alpha equals 3 above rho and beta?
Mm-hmm. That's nice. Absolutely. So this is negative, what, sine over cosine? I guess I could do the first case here. Boom. That's about as simple as I can get on that side. This is subtraction of two cosines. And I'm stuck there.
Oh, this one actually.
Subtraction, oh, difference of two cosines is the bottom one, right? Is the bottom formula? So that's -2. We did that one earlier here. Sine of alpha plus beta divided by 2. So that's gonna have to, that's alpha, and that's beta.
It is pretty satisfying, right? QED or F.
After this one particularly, right? Uh-huh. So let's see, this one is going to be alpha plus beta divided by 2. So 3x, 4x is this x. And this is sine of subtraction of the 2, right? So 3 minus 1 is 2. Sorry, this is 2x. Is this 2x? The first one is 2x? And that's x on that side. Cool. And then that's the top one here. This is just 2 sine of 2x, both of them, and cosine of the difference here. So 3x minus what is 2x? 2x is x. In that case, yep, these guys are gone. The 2's are gone. And I'm left with something that looks like this, which I declare those two to be exactly now equal to each other. And great 3 letters. Love very much these days. Okay, good there, guys. With that product to sum to product formulas. Again, just moving around one to the other. Okay, one more thing that we have to do in the last section is, let me write the way the title says it here. It's identities with inverse functions.
I just had a random question about factorial. Did that ever come back, or did you just do that now?
It's like in higher mathematics if it comes back.
Yeah, because I feel like we learned it once and we like never ever use it again. As we keep going.
It becomes super important.
I was gonna say, yeah, I think that is important.
Computer science, okay. To identify, yeah, let's take a look at this. This would be kind of cool. Hold on. Let me set this up. I think we have just a little time for it too. Let me go to here. Let me go to here. Just trip you guys out since Abe asked the question. Okay, you guys been learning of like sine. Sine is, or tangent, let's say tangent. Tangent is sine over cosine, right? Or even definition. Sine is the y value over the r value, right? Or sine is the x coordinate along a unit circle. So, but those, if you think of it, those are all like graphical definitions of them, right? Like, hey, what's the unit circle? I gotta draw it, right? Or what's a point in space? I gotta draw it, right? I wonder if I can say this formula for sine. Let's see if they give it the way I want it to be given. Okay, so yeah, that's all fine and dandy. Okay, computationally though, what does sine mean? That's sine.
Oh, there it is.
So algebraically, computationally, like how do we think of this? How does the calculator derive sine when you punch in sine of 52 degrees? It doesn't look, hey, let me look at a unit circle. It doesn't do that, right? So, it's a S and it's the sum. It's a capital Greek letter S. So yeah, guys, this is it right here. Could you imagine? So this is where it comes in. There's your sine formula that's the formula for it. This is the way your calculator thinks about it right here. Isn't that crazy?
Yeah.
Thanks, Abe, for asking the question, because
That's
it
just
totally
nice.
spawned a whole new discussion.
There
In
should
fact,
not be English
uh-huh,
punctuation
there's
in
your-
the middle.
Yeah.
there's all of them.
What are the exclamation points?
It's
for?
like five factorial, it's like 5 times 4.
Then you get to say it like
Yeah,
it's.
so it's
2n+1.
if you have 4 factorial, which means it's 4 plus times 3 times 2 times 1. It's the
Ah.
number multiplied times the
Distance is 0.
integer values. There you go. Integer values going all the way back to 1, and you multiply those together. Anyways, that's kind of cool. That is so crazy cool. But there it is, tangent formula and secant formula, and then we know from there gets all crazy.
You guys went through science, you'll learn about big annotation, and you'll start hating exclamation points.
How do they come
But I'm
into
not
computer
doing that,
science?
So it's all good.
So.
Did they come in, hold on, did they come in as a function of factorial, or are they just notation?
They actually do come in as a mention of factorial, because when we're doing big annotation, which is more or less a way of deriving how fast an algorithm or program can run.
Oh, okay,
Factorial plays a big part in that because of how computers these little kind of ways they're on.
That's cool, okay. Okay, guys, one more piece to go with 10 minutes to go in the lesson learned. Don't do computer science.
What?
Okay. So now we have this here. I think we're,
Good skill to know. It's just fine.
I don't need it. I feel satisfied when I can teach my mother how to do something that Google does.
okay, so evaluate this, guys. I need to know what sine of arc sine of 3/5 plus arc tangent of 2.
No, that's just sine inverse 3/5 plus. Inverse 2.
Well, no, because the arc sine whatever is 1.
Here's where we're stuck. If it was like this, and then arc sine of this, which we've done in the past, would have been just fine. But what we have is we have a sum formula that's set into a trig formula. Right?
Always sine.
It's a sine of all of that at the end.
I don't even know where to start with that.
Well, we're not going to do so we're not going to do product to sum to product. That was just a certain section. We just want to deal with the addition, sometimes the subtraction formula for these guys here. So let's do this here. Let's see. You know what? I'm going to do this here. If I'm going to take the sine of something, tell me if you guys agree here. This guy is just going to be sine of A, whatever A is, and that will just be sine of B. True, true. Hold on. If that's true, hold on. Then I actually have, what's a sum formula for sine? Sine of, so sine of A, sine B. Are we good there?
It's not much better than
No.
do sine of arc sine of 3/5.
Yeah, but here's what we've done by doing that. We've allowed for us to, yeah, we've done that. This would be complicated if we did it that way here. We're going to simplify that. So now the question is, how do you simplify A? How do you simplify B? We're going to go over here. We're going to say to ourselves, hold on, this is a triangle, isn't it?
Inverse?
Uh-huh.
Can't you just flip it?
Not upside down. It's not reciprocal.
Oh.
So let's do A. This
Yeah,
will be
what
our,
is the inverse in notation? I don't even know what that is.
I mean, you heard a sign that only one, but. You know, how people say something. One of them.
to make sure we have enough time
3
here.
and 5, so 5's the hypotenuse and, well, 3 more by triangle,
Yeah, so that means 3 is the opposite side of A, right? B is the hypotenuse, and this side is 4. Okay, I got my A angle. Let's go get my B angle. Here's my
but.
B
Wait,
angle.
why did you circle the 4?
Oh, I don't know, because they solved for it, I guess, but I can erase it. B. Oh, okay. So I'm gonna go opposite, right? Opposite over adjacent, because I can write 2 as a 2 over 1. And what would be the hypotenuse here?
Square root of 5.
Square root of 5. Cool. Okay, and then do I have all I need now?
What's the
Ooh, I don't know how, yeah.
So notice I have inverses here and I have inverses here, right? But then when I get down to my formula, because I've made this into an A value, right? I don't have any more inverses. And what I really want is I just want the sine of that. We good? So I really have this. Don't write this one down because we'll simplify this in just a second here. What's sine of arc sine of 3/5? Right, because I've already built my triangle, right? I built my triangle, I already got my pieces there, right? So for me, finding the, yeah, sine of A is just going to be 3/5. We good?
Well, that's a really easy one.
So just because we're able to break it down into in the individual piece that we had before, remember that how we had inverse tangent of sine tangent or sine of cosecant inverse. So by doing this little piece right here, we're able to individualize the trig function and its inverse. So I got myself a 3/5. What's cosine of B? Since I figured the angle already.
So cosine of arctangent 2, but that is just confusing.
Have we built our triangle though?
Just,
Yeah, so let's do this one here as well, because this would be, I'd rather spend the time to make sure that this is, I'm trying to find cosine. I'm sorry, guys. Let me put it, let me put it conceptually together, just after this here. So we've built our triangle here, right? And this is what we've done before. We've done this earlier. So once you build a triangle, you're trying to say, okay, those numbers allowed me to build my triangle. Now the question is, what's my cosine of that triangle?
A 1.
Right, 1 over root 5, right?
so 5/4. For this one, I think.
So you're using the y over r, y over x, right?
So you get there?
In the way that you're just going back to the fundamentals of y, like cosine is y over r, cosine is x over
Yeah,
r.
or hypotenuse adjacent. So A, we'll catch up with you just a second here. So cosine of A is going to be 4/5. Oh, easy, well, you said 4/5, right? That's what you're saying. Sine of B is going to be opposite over hypotenuse. At the end, it's 5 root 5. It's 3 over 5 root 5 plus 8 over 5 root 5, which makes 11 over 5 root 5. Okay, the remaining time, let's actually jump back. Let's take a look at, hey, let's break this down. I think it'll make sense once we break it down. So that's the math behind it here. So here's our issue. Let me rewrite it again, just so we don't, and then let me rewrite it in terms of this way. It's a little faster to see it that way. Okay. Okay, question is this, where are we stuck? we are stuck because we are gonna add two inverse functions together, and then we have to take the sine of it. Sine cannot just be distributed like this, right? But hold on, we do have a formula for the addition of angle, because these guys are angle measurements, right? I can put theta 1, right? And I can put theta 2 in here if I wanted to, right? Because those are two angle measurements. But hold on. Yeah, or I can use A and B. So maybe just for computation's sake, I'm going to just use this is theta 1 and theta 2. So I say to myself, you know what? Hold on. I have a formula that allows me to take sine of theta 1 and theta 2. I have a formula for that. And the formula for it is sine of theta 1 cosine of theta 2 plus cosine of theta 1 sine of theta 2. Everybody agreed there?
What I'm confused on is why the triangles?
Uh-huh.
Like,
Sure.
you just got rid of the inverses, but I don't know how.
Sure. And so now let's put my inverses back. So technically the sloppy, the big way of doing it is this right here. I'm going to take the sine inverse of 3/5. I'm going to take the cosine of tangent inverse of 2 plus cosine of sine inverse of 3/5.
Goes back to the thing where if the inverse is on the inside and one was on the outside, they just cancel out, and it's just the.
That's
Yeah,
only
uh-huh.
for the same,
Yes, for the sign.
the sign one, yeah. The other ones I have no clue, like I don't.
Sure.
Forgot about that stuff.
Well, tangents just sign.
Yeah, but let's see first what we did. We have put them into individualized inverse and trig function combinations, right? That's what we know how to do. We were stuck up here because we had this little plus sign. Somehow we're supposed to take the angle measurement, then we're going to actually add them together, and then we're going to take the sine of it, right? Couldn't do that because we don't know what the angle measurements to even add together. But the sum rule for sine says, hey, look, it's a combination of taking the sine and the cosine of those guys. So now, yeah, these guys will cancel. That's 3/5. Now I'm stuck. He's about to answer your question. This one, it worked out fine.
Oh, hold
So
on.
wait, so you're using the inside value to solve the triangle for that value, and using that triangle for the outside value?
Yeah.
Well, think about it, only if I just.
So
find theta
tangent will produce
from-
a triangle for me because
So
tangent
you're-
is,
You're given 2/3 of the triangle, you can come back and find the third side, you can use the triangle to find the thing on the outside that produces.
Okay, now it makes sense though. I just remember when we had to
yeah,
use.
2/1. I got a root
theta
5 in
equals
my hands.
tangent inverse of said
So now we know that
inside the
cosine is
parentheses.
just gonna be 1/5.
Yes, absolutely.
And then
Oh.
And this
I
one's
get it
sine cosine.
now.
Okay, I can make my triangle. Triangle sine is that one over that one. That's a 4, but the cosine of that is 4/5. And then last
You have to
one,
make a triangle every time there's an inverse inside.
yeah, so we just make it
You
once.
don't need to, because you have two sides, you just figure out what the first one is.
Inverse
Yeah.
of a function gives you an angle. From that, then you have cosine of an angle.
Okay. It all
Yeah.
makes sense now. That
Yes,
was
it does.
very
That
confusing.
was a very good explanation.
Yeah, thank you.
Thank you. Cool. I thought that makes sense. I'm gonna keep that. I'm gonna save that slide. Cool. Thanks, guys, for your feedback as well. Okay, guys, anything to turn in today or no? 5-4. If you guys can put it on the last desk out there, and I'm
Hey,
gonna.
you can take care of my homework today. That's super helpful.
Sure, you guys, absolutely. I thoroughly enjoy teaching you guys. I think it's just awesome.
I have to get up to get stable at my desk, so.